Data modeling and star schema, the foundation of every successful Power BI dashboard. Have you ever built a Power BI report where the numbers didn't match, filters didn't work correctly, or the report became slow as more data was added? The problem often isn't Power Query or DAX, but it's the data model. Today let's understand what is data modeling, why do we need it, what are relationships, what is star schema, what are fact and dimension tables, how we implemented this in the project. Let's get started. So what is data modeling? Imagine you have data stored in multiple Excel sheets. One Excel contains employees table, another Excel contains employee details, another Excel contains employee ID, another Excel contains location. So like that, several Excel sheets, each table contains valuable information, but here's the problem, none of them know about each other. If I ask how many employees are located in Hyderabad, how many employees are located in Bangalore, so the Power BI cannot answer unless these tables are interconnected. That's exactly what data modeling does. Data modeling is the process of organizing business data into a logical structure by creating relationships between multiple tables. Think of it as creating a roadmap that tells Power BI which table connects to which table, which column should be used, how filters should travel. So if we take it in a real life analogy, imagine a hospital. There are separate departments: reception, doctors, pharmacy, laboratory, billing, and each department stores different information. But all departments use one common thing, that is patient ID, because patient ID connects every department. Similarly, Power BI uses keys like employee ID, project ID, date ID, so to contain tables, to connect tables. This is data modeling. So without data modeling, we cannot avoid duplicate data, we cannot fix wrong calculations, we cannot fix slow reports or any maintenance. With data modeling, we can have faster reports, accurate KPIs, easy maintenance, and better performance. So the relationship we need to understand. Suppose we have two tables, one is employee table, another one is tickets table. Let's say in employee table we have employee ID and names, employee names, and the ticket table we have tickets and employee ID and story points. Let's notice something. Employee ID exists in both the tables. There's a common column. That becomes the relationship. Employee ID, tickets, employee. Now Power BI understands that Ravi in one of the table is completed these many story points. Without relationship, Power BI treats them as a completely separate tables. So we have four relationships here. One is one-to-one, one employee, one passport, rarely used; one-to-many, most common; one sprint, many tickets; one employee, many stories; one project, many tasks. So many to one, reverse one to many, mostly created automatically. Many to many is a complex, usually avoided unless it is required. So in the project, if in a project there is one sprint, contains many tickets, one employee works on many stories, in one domain contains many tickets. These are all one to many relationships. So what is star schema? Now comes the most important concept. Microsoft recommends use star schema. Why? Because it is simple, fast, easy to maintain, high performance, scalable. Imagine a star. At the center, one large table, around it multiple smaller tables. It looks like in a star. The center table is called fact table. The surrounding tables are called dimension tables. This structure resembles a star, hence the name star schema. Fact table. Let's understand fact tables. A fact table stores business transitions. numbers, measurements, metrics. It answers questions like how many, how much, how long. So notice like mostly numbers, story points, hours, capacity, utilization, cost, revenue, sales. These belong to in fact tables. So in the project, like if you say there are tickets, capacity of the team members, allocation, utilization, how many defects. So every KPI comes from these tables. So what is the dimension tables? Now the fact table tells us what happened. Dimension table tells us about what. They describe the facts. Employee table, sprint table, domain, media, sales, CRM, compliance, status table, done, open, in progress, blocked, date table, January, the months, quarter, year. These are descriptive, so not transactional. So in this dashboard contains fact tables, that is like tickets, capacity, allocation, defects. In dimension tables, employee, sprint, date, project, domain, status. Together they answer business questions like which sprint has highest velocity, which employee completed maximum stories, which domain has highest defects, which project has maximum carryover, which team is utilization. So why star schema is faster? Suppose you store everything in one GL table, 100 columns, 1 million rows, Power BI becomes slower. Now split it into small employee table, small tables like sprint table, domain table, fact table. So Power BI loads less memory, relationship become efficient, DAX becomes faster, reports refresh faster. So always create one fact table connected to multiple dimension tables, avoid duplicate columns, use one-to-many relationships, create proper date table, avoid many-to-many whenever possible, use meaningful table names. So the common mistakes here is creating relationship on text columns, keeping duplicate employee names, using multiple date tables unnecessarily, building one huge flat table, using many-to-many relationship without understanding them, ignoring star schema. So in the board, we receive data from Jira or Excel or whatever the source files, and we use this. So the key takeaway is the Power Query prepares the data, the data model gives its structure, relationship connect the tables, star schema organizes them efficiently, fact table stores business transactions, and dimension tables provide business context. A well-designed data model is the foundation of every fast, scalable, and accurate Power BI solution.